This time, I would like to introduce one of the first mathematical equations you'll face in almost any chemistry course. So this topic deals with finding the atomic mass of a molecule. Now remember, an atom can be found by just looking at the periodic table. So one of my favorite periodic tables to use is this one, and hopefully it shows up on the camera. It's just called Periodic Table 2017. Maybe if you're watching this in 2018, it'll say 2018 on there. But I've been using this for years, and I always suggest it to anybody I'm teaching or tutoring. So let's go ahead and open it up. And this is not a sponsored video by any means. I just really like to share this one and just to let people know how good it is. So here's the periodic table, as I'm sure you probably know. And it divides the periodic table based on the properties of the atoms or elements in it. And it's just a really helpful tool, real easy to read. And there is like a paid version too, but that's $4 and it does some math for you, but realistically, you should be able to do the math anyways. So I highly suggest this. If you want to get the paid one, go for it. Now, labeled underneath the atom is its individual atomic mass. So let's say you were asked to find the atomic mass of barium, for example. And barium is right here. And so we see on here that barium's atomic mass is 137.327. So it's as simple as that. Now, you have to add up all the atoms in a molecule. If the molecule has more than one atom in it, so therefore if it's a molecule, you're going to have to add up the individual mass of each atom. And let's get into some examples of that. Alright, so our first example is going to be water, or H2O. And how we're going to deal with this is we're going to get out a handy dandy app again. And we see on the app that hydrogen, up in the upper left, has an atomic mass of approximately 1. And we have 2 hydrogens. So this 2, remember, only belongs to H, not to the oxygen. So we have 2 H's, and each H equals 1 atomic mass unit. So we're going to say 2 hydrogens equals 2 times 1, which equals 2 AMU. But we also have an oxygen here, and there's only 1 oxygen, so we'll write 1 oxygen equals, let's go to our app. We see oxygen is right here in the 6th column. If it would focus. There we go. Oops, that was sulfur. There we go. Okay. So oxygen. Come on, focus again. Well, I will just tell you what it is. Oxygen is approximately 16. Realistically, it's 15.99. But for this purpose, we're just going to call it 16. If you're actually doing measurements with it, you would probably call it 15.99. So we're going to say 1 oxygen equals 1 times 15.99 over 16. So I'm just going to say 1 oxygen equals 16 AMU. Now we just add these two numbers together to get 16 plus 2 is our total, which is 18 AMU. So the molecular mass of H2O is 18 AMU. Or actually, technically, it's atomic mass, I guess. All right, so our next example is going to be sodium sulfate, which is Na2SO4. So the Na here just means sodium, and SO4 means essentially sulfate. So now we see we have 2 Na molecules, or Na atoms, sorry, that was a bad way of putting that. So this 2 goes with the N and the A, because Na is sodium, it's just 1 atom. So, well, there's 2 atoms technically there. So we're going to say we have 2 Na, which equals 2 times, get out the periodic table again. So it's going to be 2 times 22.99, we'll say. And that's going to equal something. We'll figure that out in a second. And then we have an S, which is sulfur. So we have 1 sulfur, which equals, let's see if it'll focus, 32.07. I'm just going to round it up. Normally you wouldn't round it up if you're doing calculations. For my purposes, I will though. And then we have 4 oxygens, it looks like. So let's look at this again. This S and this O are separate because sulfur is one element or atom, and oxygen is a different atom. Now, if this oxygen was lowercase and it was capital S lowercase o, then they'd be the same atom. But we're not going to see capital S lowercase o on the periodic table, so we know that these are 2 separate atoms. So let's say we have 4 oxygens, which is going to equal 4 times 16. So that's going to equal 64. I know that one off the top of my head. Now this sulfur up here, actually, you know what? Let's say it's 32.065, like it said on the periodic table, just to be more exact. So like I said, that's what you're going to do realistically anyways. So that's going to be 32.065. And then we had 2 times 22.99, which is 45.98. You can just do that on a calculator. I did it ahead of time so we could save a little bit of time. So now we'll add all 3 of these together, and the total is going to be 142.045. And sometimes you'll be either see this as grams or AMU. It really depends on the type of calculation you're doing. I would stick with this for now. Later on, we'll put it in grams per mole when we do a certain calculation. Probably AMU is your best bet for now, though. So now we have a situation where we have MgOH2, or magnesium hydroxide. So for this molecule, we can see that we have an Mg here, an O, and an H. Now, we also notice that there are parentheses in here. Now, this might be a little confusing at first. We haven't seen this yet, but it really follows the same rules as before. So what this means is that we have 1 Mg, so I'm just going to put 1 Mg, which is equal to, we're going to go on the periodic table, we see Mg is here, and we're going to say 1 Mg is equal to an unfocused camera. Perfect. No, 1 Mg is actually equal to 24.3. I'm going to round it to 24.31. It's really 305, but I did the calculation with 31. In actuality, probably put 305 there. I just got lazy. And then we have 2 hydroxide ions, and hydroxide is just OH minus. There are 2 of these. They cancel out the +2 charge of Mg. I'll get into more of that later on. But this means we have 2 oxygens, and we have 2 hydrogens. So this 2, even though it's right after a lowercase h, it actually applies to both the H and the O. So we'll say we have 2 oxygens, which equals 2 times 2 times 16, which is equal to 32. And these are all in AMUs still. I didn't write that in the last problem. That was my fault. And then we have 2 hydrogens as well. So 2H equals 2 times 1. 2 times 1, because each hydrogen is 1 AMU, which is going to equal 2 AMU. So you add all these together now, and we are going to get 58.31 AMU. So the total atomic mass is 58.31 AMU for magnesium hydroxide. So hopefully this made sense. Feel free to ask me any questions, and I will get back to you as soon as I can. Until next time, see you guys later.